Yeah, me too.
So lesson 21, I got 0.9855725, so 0.986.
Yeah.
And then I times it by the standard deviation of the two categories and got a covariance of 1533.734.
Yeah.
Cool. Another thing was annoying though is the covariance, like, what's it called?
Covariance.
Like function on Excel would not come up with the same answer as this. So it's driving me crazy.
Oh, really?
Yeah. So I had to manually rather than just have, use the covariance function. So it makes me wonder what the co-function variant or function process is,
Yeah, well, I just use the, linear regression stuff that's in the quantitative inference procedures.
Okay. Let me open that one up.
Quantitative inference procedures.
Okay, and then you did
a linear regression tab. It's got like the covariance and R and all that stuff.
I was trying to go over, but I kept adding. I've taken 2 different Excel classes, and when I do stupid stuff in Excel like I just did, I'm like, what is wrong with me? Instead of going over, I was adding them.
Yeah.
Okay. Oh, that would have been easier. I did everything by hand on a different spreadsheet because I looked at the categorical instead of the quantitative, which makes sense that it's a quantitative, not a what a jack. What an idiot.
That's cool, man. That's cool. So I got a scatter plot that looks, I don't know, I like share my screen or something. Screen share. This one. And my scatter plot looks like that.
That's what mine looks like.
Okay. Oh, stop screen sharing. And then for question 6, I said there's a strong positive relationship between the head length and the body length. And because it's strong and positive, as the head length increases, the body length also increases.
Cool.
All right.
And then for lesson 20, do you want to go over lesson 22 now too? And then
we can do that, and then we can just hit the tests.
The quizzes. Okay, so I got the head for question 6, body for 7.
Yeah.
And then let's see here. And then I transferred over from my spreadsheet to an actual Word document. So I'm gonna put just a little bit. Okay.
Oh yeah. Sorry, I'm tired.
Oh, you're good.
Yeah, dude.
And then the scatter plot is the exact same as the one before.
Yeah.
So
then I got the y-intercept is -69.369.
Yep.
And then the slope is 7.4.
Yep, that's what I got too.
Okay. And then the equation was I just got it out of the book. Or not the book, out of the the book, the y hat equals negative, or y hat equals the y-intercept plus the slope times x.
Perfect.
So it's y equals -69.369 plus 7.4x.
All right, excuse me. Okay, so use the software to draw a regression line on the scatter plot.
Yeah.
That's just adding a trend line, right?
Exactly.
Yeah. Okay, that's what I did. So, but I don't want to say it with a ton of confidence and I'd be like, that's not how it's done.
No, yeah, that's what I just did. I just did trend line, and it seems to work fine for me. Cool. For the 13, I got the body length for a head length of 51 centimeters was 343 centimeters body length.
Okay. 43.
And if you want to double check, you just pull up that stuff again.
The spreadsheet.
Yeah, that Gahariel crocodile
Yeah.
data.
51. Yeah. Okay. Yeah. And it's on this information too. They're on the t-test for the linear regression.
Okay.
Perfect. Yeah, that's what I plan to do.
And then I got so I just visually did it. I guess as you use the slope. Oh gosh, what's the word? The slope equation. You could get it as like 3.08, but I just kind of like looked at it visually, and I got like approximately 310 body length based on the regression line.
Okay.
And in the answer sheet, it said using the calculations of the slope intercept equation, you could get like 3.08 dot something something. But it also said that the answers would vary from like 300 to 350. So I think 310 was good enough.
Sorry, let me double check what I had on here. Y hat. That's what it's called, right? A Y hat.
Yeah.
And that's just the equation that we did earlier, right?
Yeah, the Y hat equals.
Yeah. Perfect. All right, and then 15. Just the points aren't exactly on the line. So sorry, I'm like, let me look at I like just typed in the answers instead of actually looking at the.
Yeah, it's all right. Like I just said that the values aren't the same because the regression line just provides an estimate, not any precise calculation. So it's like we can estimate that a 51-inch head would be approximately 308 centimeters, or 51 centimeter head would be approximately 308 point something centimeters in body length. Like we can estimate that, but it's not any precise data collection, and it's going to vary when you actually collect raw data.
Okay.
It's not going to follow a perfect line because there's multiple variables in just head length and body length.
Yeah. Okay, cool. All right. Well, let's hit these group quizzes.
Yeah. Let's see. Lesson 21 group meeting quiz.
Sorry, give me a quick second. I finally have a two screen setup. I'm still just disorganized as can be.
Oh yeah, 2 screens are nice though. They really help a lot.
It's so nice. Yeah, that's what I put my spreadsheet up on one and then the quiz on another, and it's so nice.
Yes, sir. So I'm gonna close out of these Word documents now.
Oh yeah, that's a good idea. That's a lot of my clutter here is all these.
Yeah.
Dang it. I hate when I click on the wrong class. I don't need my religion class. Stats.
Oh, whoops, I hit the wrong data.
But yeah, dude, I started working at Cabela's again. It's sweet.
That's nice, dude.
I know. I'm so excited to do to have 3.5 again. And it's just like a seasonal spot, but I'm gonna do 20 credits. I'm gonna do 20 credits, or excuse me, 18 credits next semester. So even if I don't get pulled on for part time, I'll I'll just go to school and live off my GI Bill.
Yeah.
All right, so quiz lesson 21.
Yeah, dude, 3.5 was the best. I love that.
Yeah, it's way sweet. All right, the correlation coefficient is used to quantify the strength and reliability. Sorry, let me bring up my book. So I read this like Sunday night.
I'm trying to think because it's like strength and reliability. So I think a strong positive, strength and direction.
Yeah. Identify. Okay, let's see here. Sorry, I'm just finding the book real quick.
Excuse me.
The direction and strength.
Is it?
Yeah, direction and strength. Oh, of a linear.
A linear relationship, yeah.
Yeah. Yeah, perfect.
If the correlation coefficient is negative when one variable increases, the other variable tends to decrease, right? They're going in opposite directions when it's negative.
Yeah, and an increase in a variable is associated with a decrease in one. We say there is a negative association between variables.
Yeah, okay. The effect of outliers on the correlation coefficient is not significant.
Oh, jeez Louise.
I don't know. I think outliers don't affect it very much. I think the line, if you have like one outlier, the line's gonna be fine. Then again, if you have like 15 outliers, and is it really outliers?
Yeah.
Is it really an outlier?
The effect of outliers. An outlier is any point that far from familiar. Each following. Sorry, what are we asking? It's not significant. Let me see. I'm gonna say it's false because it says like, so what can you say about the effects of the outliers on a correlation coefficient? It's the outliers can dramatically affect the values of a correlation coefficient. So I think that's false. Yeah.
Okay.
Oh my god.
Dude, I'm just getting over one. I know the two.
It's the worst. I don't know if mine's actually a cold. They're just allergies that I'm not used to from moving to Boise, but it's hitting me hard.
Excuse me. Input the correlation coefficient. Okay. Wow, that's a lot of data points.
Yeah. And then it has this one random one at 260 golf.
Yeah, I think it's a calculation of some sort.
Okay. All right, and then let's see here. I got the durations. Now I need the weight.
Okay. All right, so trying to find the correlation coefficient. 0.901.
Yeah, that's what I got too.
Okay.
That scatter plot looks like garbage.
Yeah, that's what I was looking at. What is that?
Yeah.
What is the direction and strength between weight and duration?
Sorry. Strength.
So trend line is positive.
Yeah.
I don't know. How do we tell if it's strong again?
I can't.
Yeah, if it's R is high, it's strong. So yeah, it would be a strong positive, wouldn't it? Because if it's R is closer to 1, it's strong.
And if it's closer to 0,
it's zero, it's weak. If it's closer to negative, if it's closer to -1, it's also strong. Just in strong negative.
Strong negative. Yeah, and this is the positive. It's going up.
Yeah.
Match the scatter plot with each correlating coefficient. So awesome. 4 would be -1, right? It's just got like a perfect slope down in the line.
That would make A1. So
A1?
That would make
4, 1, right?
that
And
would,
then
that would make 4 is -1. That would make 1 1.
R equals 1. Yeah. Yeah.
Okay.
Let's see here.
Sorry. Then -0.95. That I think that would be 5.
Yeah, that's what I was thinking. And then 2 for the other one, or for positive 0.95.
Yeah. And then I'm thinking 6 would be -0.6. And then
6
3 would be 0. Does that sound right?
Yeah, because there's like not anything really going on with that. Or 6 is definitely. I mean, 6 is definitely a negative. And then 5 is just flat, so there's no. Oh, jeez.
Well, bless you. So 3 would be 0.
Yeah. So we have 3, 5, 2, 4, 1, 6, right?
What?
So going in order from top to bottom, it's 3, 5, 2, 4, 1, 6.
That's not what I have. So is
What,
your top one -1?
No, okay, I lied. My top one's 0. So 0 is 3. Negative
Okay, so,
9. Okay, so 0 is 3.
Yeah.
Negative 0.95 is 5.
Okay.
Positive 0.95 is 2.
Okay.
Negative 1 is 4.
Okay.
Positive 1 is 1.
Okay.
Negative 0.6 is 6.
Okay, that's what I have too. I guess I didn't have them in the same order on every single one this time.
Yeah. And now it's a good thing we dealt because I just start spouting stuff off.
I was like, what? What's going on? Okay. Open up this data. Okay. Come on.
Yeah, I hate when one opens and I can't do anything on the other one while it's waiting for the other one to open.
Yeah.
Super annoying.
So does the gender matter in this one?
Mine still hasn't
I think
popped up
it
yet.
does. I think gender matters. I think. Okay, let's see what's the questions. Maybe not.
There we go. Cool. But wouldn't it just be the score versus the confidence? The gender's not an issue.
Yeah, I think you're right.
Okay, let's see here. Delete all this information. Oh, not all that information. Holy cow.
Oh, come on, there you are. Purple. Delete. Oh, good lord. Yes, don't delete that. Holy cow, that was scary.
Now I almost deleted like a bunch of stuff on the spreadsheet. Like, oh no,
Yeah,
I have to redo
this. Me too. I was like, what is going on?
All right. So I plugged in my scores and confidence. I got a 0.728.
Not quite there yet.
No, you're good.
Okay. Yes, 0.728.
Cool. Positive and strong. Yeah, man, we sound like
Yeah, right.
I feel bad for watch this video.
Yeah, it's definitely positive. I just like what. It's closer to 1 than it is to 0. So yeah, positive and strong.
It does look a little more scattered, but
yeah. I'll submit and we'll see what happens.
Oh man, we only have 10 questions. That's the best thing ever.
I know, right? That's what I was thinking.
Yeah.
And we got 100%. First try. I like to see.
That's what I'm talking about. Save us some time.
Yeah, so now we do lesson 22.
Week 12. Lesson 22.
Just a quick minute, dude. I gotta go grab something real fast.
No, you're good.
All right. I am back. Can you hear me?
Yeah.
Cool. Oh, let me turn on my camera. There we go. Cool. So
I feel like I should,
22.
what in the world? Like,
What's going on?
no, I'm just looking at it. So it says like given the equation y equals 2 plus 1 5 times x. What is the y-intercept? Do we go off of the x?
That's that equation. So that's the y hat equation.
Yeah.
So it's the y-intercept plus the slope times x. So the y-intercept would be 2.0.
Okay. Then 1.5 for the slope.
The linear regression equation that what is the predicted value of y when x equals 16? Well, I can calculate that real fast.
It's 1, right?
Yep. It is 1. So I need to do the math efficacy.
Is that the same one we just did?
It is. So what are we looking at then? Make a scatter plot of the 3 data shapes introduced in the reading. Which shape best describes the data? Hot dog, hamburger, banana. Hot dog?
Yeah, I don't know. Looks more like a hot dog to me, but let me just look at these real quick. Yeah, hot dog. Yeah, definitely a hot dog.
Definitely hot dog.
Cool.
Yeah.
Based on the shape of the scatter plot you produced in the last question, what can you say about the appropriateness of using simple linear regression to model these data? So
I
that
think
would be.
I don't know.
Sorry.
That's kind of like a weird question. I think it's appropriate.
There's
It gives us a correlation, but I guess the only thing that might, I don't know.
It's appropriate because if it's for the hot dog shape, it's an appropriate. There is a significant linear relationship, and then if it's a hamburger, then it's not appropriate, and then if it's a banana, it's not appropriate.
Oh, are you actually looking at the book right now?
Yeah.
I don't remember that part. Of course,
Yeah, there's just a little chart that says like what it's got going on. So
okay, that's cool. Yeah, then totally appropriate.
well, hopefully I'm looking at the right thing. How many observations?
Well, let's see. It's not appropriate. Okay, yeah. So there's only one option for appropriate. Okay.
Yeah.
How many observations are in the data?
It should tell us here, right? It should just count them. So 4 through, you think it would just count them, right?
You would think.
Okay, 4 through
142, so 138.
I think it'd be 139, right?
139.
4.
Oh, because you're counting 4. Yeah, so 139.
But what is x here? Okay, whatever. Yeah, 139. I'll do a quick count.
I swear I saw it say how many there were, but I could be mistaken. I guess I am mistaken.
Yeah, 139.
139. Okay.
What is the y-intercept? The y-intercept is
1.296.
Yeah, dude.
And slope is 0.042.
Perfect. Dang it, I was hoping there's only going to be 12 again.
I know, we got 15. What is the predicted value of y when x is 4?
So 4 times the.
You probably change. So should be 1.462. Is that what you get?
Let me see real quick. Times 4. Oh, that doesn't look right. 1.462.
Yeah.
Cool.
So under the in the chart or the it's too late in the Excel sheet.
Mm-hmm.
Under that last group of numbers says confidence and prediction intervals for regression response right above the scatter plot. If you change x, it'll manipulate the data.
Oh, that's why it's highlighted, so I can change it to whatever I want it to be.
Yeah.
I just did. All right, thanks, man. Good looking out.
Well, no, it's good you did the calculation because I wasn't 100% sure that was what we were looking at.
Yeah.
Cool. So the confidence data resulted from students evaluating their confidence for each question. Oh gosh, this is too much words. This is bad. Okay, evaluating their confidence for each question on a scale of 1 to 6. What is the maximum predicted value of y for these values of x?
It's 6. If we go up 6, it's 1.546. So if we just do, if we change it to 1, it's 1.3. Change it to 2, it's 1.379. And it just keeps going up. So 6 is
6 is 1.546. Yeah.
Yeah. Okay. Well, I don't remember reading about that.
How many explanatory independent variables are present in simple linear regression? Oh, I remember reading about explanatory variables, but what? I don't remember that part.
Okay, let's see here. Predictions, regression. Okay, independent variables. Regression allows us to write. We can predict why.
I think it's got to be more than 2. But it's not just 2, and it's not just 1. Because 1 can't create a linear line. 2 might be able to, but it's not a very trustworthy line because one of those could be an outlier of the actual data set.
So
I'm trying to think.
Explanatory. That's what I need to look for.
Yeah, explanatory is X basically. So in this one, we said we had 139 variables. So we have 139 explanatory variables and 139 response variables. So it's like not.
Wouldn't it be more than 2 because our X is 6?
I think it's asking. It's just asking in general how many explanatory independent variables are present in simple linear regression. It's not necessarily asking for our specific data set.
Well, you can have, as long as you have 2, you can make a line.
It's true.
me see if I can.
There's not anything in. There's nothing in the book that says anything about explanatory variables specifically.
So a linear regression attempts to model the relationship between two variables by fitting a linear equation to observe data. So one variable is considered the explanatory variable and the other is considered the dependent. So it'd just be one. Oh no.
No, you'd have to have two of each to create a linear. At the very least, two of each to create linear.
Well, is it asking how many? But I'm like, what I'm wondering is it explanatory variables? But even if you just have here, I'm gonna delete everything below, just one of each. And oh yeah, you're right. It has to be at least two because like a 2.3 or something like that. Yeah, it have to be at least two of each.
Yeah.
It doesn't say at least. This is more than two.
Yeah. So that's where I'm a little confused because it just says two.
Yeah.
And I'm like, does that mean at least two, or does that mean it has to only be two? Like, what are you asking?
Yeah. Because two. Well, let's see. What's the definition of simple? Is it just two? Well,
I'm watching the videos, kind of skipping through. The guy doesn't say anything about unnecessary number of anything.
whew. Well, I guess we can just put one.
We know it's either two or more than two. So if it's,
You want to go with more than two or two?
let's just go with two.
Okay.
It's
For
two
both of them? Good. For dependent and independent?
Yeah.
Okay, so I put two for both of those.
Yeah. A company in South Dakota manufactures hard hats used in the mining industry. They record measurements on all hats they produce for quality control and planning purposes. The measurements they collect include the hat size, circumference of the hat, and lengths of the major and minor axes. Meaning the company wants to predict size of hat given the circumference. What is the response variable? Response is your dependent variable.
Yeah.
It's a dependent, so they want to predict the size of the hat, so the size of the hat would be the response variable because that's what you're trying to predict. The circumference is the same. Well, it's not the same. Let's see. Response variable is what you're trying to predict, right?
Yeah. But we're trying to predict circumference. So would it be hat size trying to predict the circumference?
Well, it says meaning the company wants to predict size of a hat given the circumference.
Oh.
So they're given circumference. So we're trying to predict what size the hat is going to come from that circumference, if I understand that correctly. And that would mean...
Is the variable being predicted? Let me read.
So it says a simple linear regression is a method used to fit a line to data. This provides a powerful tool, blah, blah, blah. Regression allows us to write linear equation that models the relationship between an independent variable x and a dependent variable y, which we can use to predict the value of y for any given variable x.
It would be.
So it would be the hat size because that's what we're trying to predict.
Yeah, because it is being used to predict.
So it would be the hat size of the hat because it's the variable being predicted.
Okay, cool. That's what I
put. Okay. All right. So I'll submit quiz and hopefully we get 100 so we can move on.
First time go.
Okay. We were wrong on a few. Holy cow. Okay. So basically 9, 10, 11, 12, 13, 14. We're all wrong.
Okay, 9, 9, 10,
11, 12, 13, and 14. So 9 through 14, we're all wrong.
So I'm going to put more than 2, I guess, for 13.
Yeah, and I think it should be. I think they should be the same.
Yeah,
because if you have a deep, yeah, if you have a dependent or independent variable, you have to have a dependent variable in order to put it on the scatter plot. In order to put it, in order to compare the two. So I think it had to be more than 2 and more than 2 then.
So what? What would our? Oh, you know what? So what? Well, I'm trying to see what. So if we got 9 wrong and 10 wrong, then I'm imagining it's because. Well, that doesn't change it. Well, we pulled the. All right, I lied. Okay, I'm gonna take this math spreadsheet down, and then see maybe it was a different one. You know, maybe they had different information for it.
Oh, okay, I see.
It looks like it's the same, but let's find out. No, it's exactly the same. Is our we change the confidence level or? What? Round to 3 decimals.
That doesn't make sense then.
No, that's yeah.
It should be right.
Yeah, everything the spreadsheet's given us. So it's 9, 10, 11, and 12. 13, 14.
Yep. Just to be sure we had the same stuff, let me just repeat it back to you just a moment though. I need to make sure I'm doing this. Come on, there we go. All right, so 9 was 1.296.
1.296. Yep, that's what I put.
And then 0.042 for 10.
Yeah.
And then 1.462 for.
And I even did the equation separate versus the math. Yeah.
Yeah, and you still got.
Were there any announcements about this or anything?
I sure hope so. I didn't see any though.
Nope, nothing. Yeah, I don't think
anyone's probably done this one yet. It's only Tuesday.
Yeah, so I don't know.
We could email them about it.
Yeah, it's kind of frustrating because I wanted to, because like.
Just wanted to be done.
Yeah, I want to get it done, but my grade is like for me to hit that 93% mark if I can keep going on my test the way I have been, like I need to either like score really good on my final or in this study that we're doing to get past that 93 mark, get a 4.0 in this class. I'm like, oh man. So I don't want to just submit it and then send them an email and hope that it's wrong, that the computer's wrong. But yeah, what else would it be? Because we got 8, right?
Yeah, 139.
Yeah.
And we got the hot dog shape, right?
Yeah.
And
because if we did this, because we did the same information on the homework, and the R was right.
What if what happens if we swap the variables?
Oh, I don't know. That's a good.
Well, R. Let's see if R changes. And oh, R doesn't change.
But does there anything else?
The slope and the y-intercept do.
All right. Well, I'll change everything over, and we'll go with those numbers, and I'll submit it, and we'll see if that's our issue.
Yeah, because everything changes. Yeah, so I got this y-intercept of 18.690.
Here, give me a quick minute.
Okay, that's fine.
Why would they have you do it different in here than what it is in the other spreadsheet? Because does it say anywhere which one should be the independent, which one should be the or the independent versus dependent?
It does not, that I could tell.
Yeah. Okay. Whatever, I guess. Because why would that? Okay, let me see here real quick. Okay. I don't know. All right, what's going on here? Wow. Okay, so it's a big change.
Yeah, right.
So we got 9 wrong. So 18.690.
Yeah.
12.695.
Yeah. And then I got the predicted when I put the 4 in for x as 69.469.
Cool.
Then we changed it 2 to
so 6. Right, you changed the 4 to a 6 for your 12.
For what?
For 12. You got 94.859.
Oh, I did not check that. 94.859, yeah.
Okay, cool. Well, I put more than 2, and I plugged all these in. So real quick, 9's 18.69. 10 is 12.695.
Yeah.
11 is 69.469.
Yeah.
Yeah. And then 94.859. More than 2, more than 2.
Yep.
All right, let's do a little bit of that business. A little sacrilege. Well, we got
The more than two and the more than two, right?
Nope. Those
Nope.
ones we got wrong. Apparently, you only need one in those.
I guess we
Right? Because we did 2 and 2, and so everything else is right except for those.
Except for those.
Yeah, so it's 1 and 1.
So it's 1 and 1. Okay. So you want to hold up, keep your answer sheet up?
Yeah.
And I'll start my other one again. Less than 22. 1 and 1. I don't understand that because 1 and 1 doesn't make a line.
Yeah, it doesn't make sense, does it? It would just be, it'd be 1 dot.
Yeah, it'd be 1 point on a scatter plot and wouldn't do anything.
Yeah, it doesn't make sense. But all right, so for number 3, answers 2. Question 4, 1.5. Question 5 is 1. 6, hot dog shape. 7, simple linear regression is appropriate for these data.
Okay.
139. 18.690. 12.695. 69.469. 94.859.
That's question 12, right?
Yeah. And then 1, 1, and then the size of the hat because the variable is being predicted.
Okay.
Cool. So I'll just get my quiz going again and redo that. Good call on swapping those variables. I don't think I would have thought of that.
I don't know why it worked personally, but yeah.
Now it's making me doubt because the quizzes, when we do our quizzes on our own, we don't have 2 chances, or do we?
We do.
Okay, cool. All right. All right. So 3 is 2.
Yep.
4, 1.5.
Yep.
1, right?
Yep. 5 is 1.
Hot
6
dog.
is hot dog. 7 is simple linear regression is appropriate. 8 is 139.
Okay.
9 is 18.69.
18.690.
And then 10 is 12.695. Okay, and then 11 is 69.469.
Okay.
And then 12 is 94.859.
Sorry, 94.985.
94.859.
859.
Yeah. Then 13 is 1. 14 is 1. And 15 is the size of the hat because it is the variable being predicted.
Okay, perfect.
Do you have any questions?
Nope, I'm like, I'll ask any of these questions, and I forgot that I had the spreadsheet still set up.
Yeah. Cool. That's got me 100%, so I'm happy with that.
Yeah, I'll take that any day.
Yeah. Perfect.
Cool. Well,
we can go on live.
Yeah.
And then we can go over this thing, and I'll share my screen.
Cool beans. All right, let's see here. Exit out.